Welcome to this video from In 28 Minutes. Thanks for all your love, which helped us to grow to 25,000 subscribers on YouTube and more than 46,000 students on Udemy. You can find more about us on our website www.in28minutes.com. This video is a part of series of 100 plus videos celebrating my 15 years of experience with programming, design and architecture. In these videos, we talk about how to become a good programmer and a good architect. We also talk about Java related frameworks, concepts, practices and terminologies other than the varied range of tools that we make use of. You can find more details in the description of the video.
Welcome to this video where we are planning to do a quick review of most of the design patterns from the Gang of 4. Let's see how much time we can cover all the design patterns in. Obviously not all, I would cover some of them or most of them. Obviously, what is a design pattern? Basically, there's been a lot of experience in doing object-oriented programming. And these guys called the Gang of 4 came up with a list of design patterns which are basically the result of their experience. So over their experience, they thought in specific contexts, applying specific patterns had good results. So these patterns are basically those solutions. So the design patterns are basically classified into three: creational, structural, and behavior. Creational deals with how you create the objects. So it's basically the creation of objects. So any object-oriented programming is all about objects and you'd create a lot of them. So how do you create them? What are the patterns in them? That's creational. Behavioral is basically how the runtime behavior. So basically these are the patterns which are related to how objects interact with each other. So the behavior of them. And the structural design patterns are more on how the objects are organized, what's the relationship between objects and things like that. So let's get started with the creational design patterns. These are a few of the famous ones: prototype, builder, singleton, and factory. The structural are proxy, decorator, facade, adapter, flyweight, and you have a host of behavioral patterns as well. Let's get started with the creational ones. The prototype pattern. Before we get started with the patterns themselves, one of the most important thing I really believe in is the fact that it's important to understand the context of the patterns. So in which kind of scenarios I can use a specific patterns. The aim of implementing anything should not be to use a design pattern. It's more like, okay, I have this problem, I want to use a pattern to solve that. That should be kind of the way it should be used. It should not be like I want to do a project with 50 design patterns. Nope, that only leads to complexity. So a design pattern should suggest itself. So basically there's a context and the context demands the use of a design pattern. It should not be the other way around. So having said that, let's get started with the first one, prototype. Prototype is the pattern, like basically where you reuse the fully initialized instance. So basically, like if you know a chess game, like there's a specific pattern in which the pieces are at the start of a game. So the white pieces are in a certain way and the black pieces are in a certain way. Instead of making this build up every time, so you'd actually create a setup and have it ready. And whenever a new chess game needs to be created, you just clone from it. That's basically the prototype pattern. So you have a fully initialized instance ready to be copied or cloned. The build-up pattern is basically one where you try and separate the object construction from its representation. So let's take a quick Java example of a build-up pattern. I love we are looking at a few examples from our initial Java course, one of the host of courses that we have. So if you look at it, we are using a builder pattern to build the coffee. So here we have a coffee with what kind of coffee, whether you want sugar, milk, and what kind of size that you would want. So if you look at it, this particular thing, we use a builder pattern to build it. So typically, if we were using a constructor, so it would be a new coffee of give a type, give sugar. Like it would be new coffee of, let's say I'm doing this new coffee of mocha, comma true, comma false, comma large. So you don't know which one is size, which one is which, and that kind of stuff. So it's not really readable. And also, like if I want to build something with just 3 of them, it makes it difficult because I would need to create a constructor for that and all that kind of stuff. So a builder pattern makes it easy in the sense that now I can say coffee.builder.milk true sugar false size large dot build, and this would build the object for me. So if I don't really want to specify the milk and I'm okay with the default value for milk, I just need to remove that, and there you go. So you have a coffee build. So this gives me options to build any object using any combination of whatever ingredients that I would want to use to create that specific object. And one of the most important things is the fact that builder pattern returns more readable code. And the other thing I really like about the design, like about the builder pattern, is it results in like once you create the coffee object, you are not allowed to um, modify the value in the object. So that's something called immutability. Immutability is one of the like really good things if you can adhere to. If your program, the values in programs change at only certain places, then it's easy to maintain because you are not changing values across stuff. Yep, so that's the builder pattern. Builder pattern simplifies the creation of objects, results in more readable code, and also gives you a lot of flexibility in how you build your objects. The next one is Singleton pattern. This is kind of the most famous of the design patterns, I guess, and one of the simplest ones to implement. So basically, in a JVM, you have only one instance of a singleton. So that's basically a singleton pattern. So you only have one instance of this class. For example, the president of a country, there can only be one president for a country, right? So similar to that, there can only be one object of this particular class present. So typically when you implement a singleton, you use a private constructor. There's also a way to create you can use enums to create singletons as well. And also if you're using JEE, then you have annotation as well. So you have an add singleton annotation. And if you are familiar with Spring Framework, then you already know that all the Spring Beans are singletons by default. So yep, that's about the singleton pattern. The next pattern is the factory method pattern. The factory method pattern is used to create a family of object types. If I really want to, I'm using a factory method in here. The get person is the factory method. So I'm creating a person factory dot get person and giving a name and what is his sex, so male. So basically, if you go to the get person, it would check if it's male and return a male object. So the fact that there are different kinds of persons is abstracted away. So uh, the abstract factory method basically handles the creation of the object and gives different types. So based on the object type, so if it's male, it's Mr. If it's female, it's Miss. So you can actually see that the absolute name and salutation would get printed. So this helps in like creating different types of objects. So how you create the objects is abstracted away. So the other parts of the application do not really need to worry about how to create an object. So they don't even know that there is a male and a female class. So all that they would be knowing is that there's a person class to which I would pass in a few parameters, and the appropriate class for that is returned back. Next, let's move on to the structural design patterns. The first one which we are looking at is the proxy design pattern. Proxy is kind of commonly used ones whenever we are talking across layers, probably in a distributed system. I need to have one object communicating with another object over the network. So you kind of create some proxy, local proxy. So it's called a local proxy. You have it on your system, but what the local proxy does is it really talks to the network. Whenever my program talks to something, it would be to the local proxy. It would almost talk as if this is in the local, like in the current system, but it's actually the local proxy is actually talking to something over the network. So that's basically the proxy pattern. You kind of represent something in the local environment. So for example, credit card is basically a proxy, right? So you have a credit card, I mean a debit card actually, I shouldn't have called it a credit card. A debit card is a proxy for what's in your bank account. So it acts like you have a bank account, but you don't, how do you carry a bank account everywhere? So you have a debit card acting as a proxy. So whenever I want to withdraw, so I kind of authenticate and get my money. So that's kind of a good example of the proxy. And also like those who are familiar with EJBs, you have the remote and home interfaces. So your home interface is kind of a proxy. The next one is decorator pattern. So decorator pattern is basically adding responsibilities to objects dynamically. So let's say I want to build 10 kinds of pizzas with 3 different types of toppings. Uh, and at the end, I also add a discount on the order. So I mean, if I'm creating a separate pizza type for each one of these things, then I would end up with 10 into 3 or 10 into 4 classes, so 40 classes, which would be really difficult to maintain. So what I would do is kind of have the decorator pattern. So each topping would be a decorator on top of already created pizza, and the discount would be a decorator on top of the order. So that that makes it easy for me to handle this stuff. So this is kind of dynamically building it up. If you look at the Java IO, you have a lot of input streams. So you have a file input stream. On top of it, I can have a buffered input stream and line number input stream. So this would read the like by line numbers. Obviously, like decorator pattern, while it solves the problem of having to create multiple objects, I mean various combination of objects, it would have a lot of runtime complexity. So you need to understand the entire thing and create the objects based on that. So Facade is another interesting thing. Again, let's assume a scenario where I talk to things over network. And let's say I want to make 4 calls over the network. So instead of making 4 calls over the network, I can have a facade on the other side, which would make those 4 calls and return the single result back to me. So that's a good example of a facade. So a facade is basically a single class that calls multiple things so that the entire complexity of that side is hidden from you. So probably like if you talk about any web applications or like you would have facades typically at the service layer. So you have a service facade which would talk to all the business stuff and return you one interface, and that's kind of the one which the UI would use. So one good facade is like a real world example would be an event manager. So I go to, let's say I want to have a wedding or something. There are a lot of stuff to do: decoration, food, invitations, arranging a music group, and things like that. And event managers can do that for me. So I go and talk to an event manager, and he would be the facade for me. So that's a good example of a facade. The other pattern we would talk about is the adapter pattern. So like a lot of times you have 2 classes doing different things, but they want to talk to each other. So one class might expect one kind of input, but the output from one class, from the class which wants to talk to it, is little different. So in those kind of scenarios, I can go for a adapter pattern. I mean, a typical power adapter. So when I travel between countries like Netherlands, India, US, so I need adapters. So my laptop charger does not work. I mean, I bought my laptop in India, and when I take it, the power cord doesn't fit in US. So I have an adapter. So I have an adapter which converts from the Indian pin structure to the US pin structure, whatever you call it. So that's the adapter pattern. And if you look at the adapter example, I mean, I have a very simple example for that. It basically converts, let's say I have so it's basically kind of a mapping. So somebody uses a short structure and somebody wants to use the full name. So I have like this is kind of a country's full name adapter. So which converts from the short to the full, and then you can actually get the adapters, I mean, mapping done. Next, let's move into the behavioral patterns. The first one which we will be talking about is the chain of responsibility pattern. It's basically a way of passing a request between a chain of objects. A little tricky definition, I would definitely say. So, I mean, it's very simple. So, let's say I approve for a leave, and my manager is the one who's supposed to be approving it. And let's say he's on leave. So, who does it go to? It goes to his manager. I mean, that's kind of a chain. So, you have a hierarchy, and whenever I have a process, then it goes through that. So that's the chain of responsibility pattern. So a good example is exception handling, right? So I have, let's say, a method 1 calls method 2 calls method 3, and method 3 throws an exception. First thing that would happen is if there is exception handling code in method 3, then it would be handled right then and there. If there is no exception handling code in method 3, it would go to method 2. And if there is no exception handling in method 2, it goes to method 1. And if there is no exception handling on method 1 also, then probably it would throw it out to wherever the program is run from. So if it's a web application, it would throw an exception and show something on the screen to the user, or it throws out something on the console. So that's kind of the chain of responsibility pattern. So you have a sequence of things which are defined. So if I cannot handle it, I would pass it on to something else. If that cannot handle it, it would pass it on to something else. This is how also the logger works. So Java util logging logger is a good example for that as well. So you have a set of handlers, and until you find the right handler, you would keep executing them. Iterator pattern again is a very common one. You have a list of items and you want to traverse between them. You kind of use a iterator pattern. So you have, like, a good example is the up down arrows in your remote control. So they use like, you can use that to traverse between the channels on your TV. The next one is the state pattern, where actually your state of an object is represented as a class. So you actually kind of completely change the object's behavior when its state changes. A good example is implementation that I have, a simple implementation I have created for the state pattern. So if you look at this fan wall control has a speed level. So depending on the speed level, so I have a rotate method defined in, there's an interface with a rotate method. So based on the rotate method, we have the new speed level set. So you can see that like if it's off right now, it would go to speed level 1. If it's speed level 1, it would go to speed level 2. If it's speed level 2, it would go to speed level 3. So this state, the current state of that specific fan is represented as a class, represented as an object. So you have the state represented as an object, and when it switches to a different object. So if I'm at 0, I would switch to object 1, switch to like speed level 1, speed level 2, speed level 3. And that's a good example of the state pattern, where you are actually representing the current state as an object. So, and whenever something changes, the object reacts and gives you, because the state has changed, it would point to a different state. The next pattern is the strategy pattern. There are a lot of times you have logic to do certain things, right? So how do you sort some stuff? So probably you want the flexibility to switch between algorithms. So probably you'd start off implementing a simple algorithm like a bubble sort. At a later point, you want to switch to let's say a complex one called like a quick sort. So those kind of things can be implemented using a strategy pattern. So let's take this example where I have a complex class which is doing a lot of logic, and in between it's calling this sort. So what we have done is we have created an interface called sortable, and we have an implementation bubble sort, we have an implementation quick sort. We don't really have the implementation in here, so hopefully somebody implements it for us. So the good thing is, now when I create an instance of the complex class, I can pass in what sorting to use. I can use bubble sort, quick sort. So without changing the class itself, so without changing the complex class itself, I can I can pass in the algorithm to use as a parameter to that. This is kind of the strategy pattern. So you're kind of taking out the strategy, putting an interface around it, and you can create different implementations, and you can switch the class which is using the strategy to, like, you can provide it a dynamic capability to switch between the strategies. The next one is the observer pattern. Observer pattern is typically used when I have a number of classes which are interested in specific event. So in those kind of things, you have this observer pattern being used. So take the typical online bidding scenario, right? So you have you have a lot of bids being placed, and there are a lot of people who are interested. So whenever there's a new bid, all the people want to know about it. So you have 10 bidders, and whenever there is a new bid, I need to inform all of them. So that's a good example of where observer pattern can be useful. Let's look at a quick example. If you're a fan of cricket, you would know about Sachin. So let's say there are a lot of fans and they want to know when Sachin scores a century. So this observer pattern implementation helps them. So basically what we would do is we would create a notifier. So we created a notifier with a list of things which want to listen. So all these Sachin fans, they want to listen on to the Sachin century notifier. So if somebody wants to register, they can call the register method and register themselves. And whenever Sachin scored a century, it's announced to all of them. So that's basically a very, very simple implementation. So you can see, like, I'm registering like a few fans, and whenever Sachin scored a century, what the notifier does is it loops to all the fans and calls the announce method on them. So this is a simple example. I mean, you can make it a little even more generic by having a interface and having that implement the interface, and instead of using the Sachin fan class directly, you can probably use an interface so that you can have different implementations of that interface present in here as well. So I just wanted to keep it very simple, so we used this simple example. So that's the observer pattern. The next pattern we want to talk about is the template method pattern. Basically, in a lot of things, there's a specific steps that you need to follow. So for example, if I'm, let's say, getting a request from somewhere, the first thing I would want to make sure is that it's valid. If it's valid, then I would want to handle. And if while handling I face an exception, then probably I would have certain way I would want to handle that. So this is kind of a behavior which I would want to have commonly for all the requests. So what I can kind of create is a template method which defines the exact steps. So I can say step 1, step 2, step 3. I know what is step 1, step 2, but step 3, the subclass should define. So that's basically a template method pattern. So basically you define the high level flow, like a lot of things, like for example, if you have a spring, like the like controller, like the abstract controller defines the high level flow, how you handle the request. And when it comes to the specific handling of the request, that would be done by the specific controllers. So template method is very, very commonly used across. The next design pattern is the command pattern. Basically, like whatever request you get, take all the details and have it as a command. So it's a good example is a waiter in a restaurant. So what does he do? I give him all this stuff. He writes it on a paper and he hands it to the cook. So that the paper is basically your object that you're passing as a command. So the cook looks at it and he knows what to do. So this is very similar to how requests are handled over the web. So whatever happens when I like submit a, like when I click a button on the browser, it creates a request, and the request is passed on to the controller on the server side. So that request is now the command object. So now like the servlet which handles that can look at it and handle that. A good example again is all the implementations of your runnable interface. So they act as a command. So whatever you want to do inside that, you do that and you pass it so that somebody can execute it. The next design pattern is the memento design pattern, which kind of captures and restores the object internal state. So if you are a game player, a lot of times in games you would have a back button to take you back to a certain scenario. You have a save button to save that specific thing. So this memento pattern is useful in that kind of save scenario. So I would save the state of the object and give the capability to be able to restore that state at a later point in time. The last design pattern we were going to look at is mediator pattern. So a mediator is basically, let's say there are 10 classes which want to talk to each other. The number of options that that there are increases multiple, I mean, n number of times. So actually it's exponential number of times. Instead of that, you would have a mediator class between them. A good example is for me a air traffic controller. So you have all the flights flying here and, I mean, not here and there, but flying a specific route, and the air traffic controller acts as the mediator. So if a flight wants to change its path, it doesn't talk to another flight to check if it's going in a specific route. No, they talk to the air traffic controller. If I want to land, if I want to take off, all that I need to talk to the air traffic controller. Air traffic controller act as the mediator, and they would make sure that everybody is, everybody is safe for most of the time. Yeah, and another good example is the ESB. Like with all the service-oriented architecture implementations, the ESB kinds of becomes the central bus. So let's say I want, let's say take a bank application or something which creates account. So if somebody creates an account, I would want to probably give them a credit card and a debit card and probably send them an email. So you might have the ESB where once it gets an order, it would actually access the mediator, and it would act like it would talk to the systems which are responsible for the credit card, for the savings account, for sending the emails and send them messages. So ESB kind of acts as the mediator down there. So there you go. So these are actually some of the design patterns that I really wanted to talk to you about. I mean, we just wanted to take a quick look through all the design patterns. This was just a very, very, very quick introduction. There are a couple of courses that we have on design patterns which would take you through like more in depth. I especially love the one on Java EE design patterns. So there are a lot of design patterns which are related to Java EE as well. So you have different layers, web, business, and also the data layer, and there are a lot of patterns associated with them, starting with the MVC pattern and a lot of patterns with how you handle data, how you handle business logic, and things like that. So I'd put the link to that course in the description. So if you are interested, do check that out. And also there is a list of free courses that we offer, which you'd see over here. And if you are interested to check out any of these courses, feel free to look at them. Until the next time.
Thanks for watching this video. We created this video to celebrate my 15 years of experience with design, architecture, and programming. We have created 2 complete Git repositories for you: Java Technology for Beginners and Java Best Practices. Java Best Practices covers my 15 years of experience with design patterns, code quality, design, architecture, and modern development practices. We talk about REST services, SOAP web services, microservices, cloud native applications, 4 principles of simple design, among a varied range of other topics. It tells you how to become a good programmer, designer, or an architect. Java Technology for Beginners focuses on the frameworks, concepts, practices, and terminologies and tools related to application development. You can find link to the repositories in the description of the video. In 28 Minutes has some of the highest rated courses on varied range of topics. You can find more information on our website www.in28minutes.com.